this section, elevation and depression, I just kind of want to recap some facts you might want to remind yourself of. First of all, these angles have to be made with a horizontal line. So if you have a horizontal line, and I'm just going to draw an example up here, and you have your line of sight, elevation is above the horizontal line. So I'm just going to put an E for elevation. Depression is below the horizontal line. Sorry, I got disconnected. So I'm going to have to draw another horizontal line, and I'm just going to use the app to do that. Hold on. Like such. There we go. I mean depression, sorry. That would have to be below the horizontal line. So that's D. So I'm showing this, guys, and I need you to kind of pay attention to some of the things I'm emphasizing or saying. I'm showing this because a lot of times people mess up with the depression one. The depression angle would be outside the triangle. But for me to use trig, I need the angle inside. And so you just got to remember that these two angles are congruent. They're both equal to each other because you're going to have alternate interior angles that are congruent. So if you need to make a note of that on your card, you can. All right. If you have it on your review packet and that's enough for you, then you're fine. All right. So on the word problems part using trig, some of the problems you're going to have a diagram and some you don't. So on number 37, and we did this one yesterday for some of you, y'all did, but I want to talk about the labeling. Okay, you have a 17-foot pole. This is representing the pole. So the 17 goes there. It also says that the wire is 20 feet long. The wire is this diagonal piece. So we're putting the 20 feet there. Sorry. And then it says it is attached to the pole 15 feet from the base of the pole. So this is the base down here, the pole. If I go 15 feet away, I'm going this direction. So there's your 15 feet. The question says, what angle does the wire make with the ground? So the ground is the horizontal. So that's my unknown and that's my X. Okay. My concern is when we're doing this, we should be focusing on just the right triangle to use trig. And in the right triangle, we should only be using the adjacent, which is the 15, and the hypotenuse. I cannot use the 17 because that's going past, it's bigger than the right triangle. So label your sides, then give the trig equation. The trig function that deals with A and H is cosine. And because we're trying to find the angle, the X is inside, you do the inverse. Okay, so X is equal to the cosine inverse, that's that -1, of adjacent side, which is 15, over the hypotenuse, which is 20. And this part is your calculator part. Okay, this is the part you do want to show on the test, because if for some reason you type something wrong, but I see that you're showing the correct setup, I can still give you full credit. Okay, if I don't have evidence that you're showing mastery, that you really understand what you're doing, because that's what a test is to evaluate your degree of understanding, then I can't give you credit if you make an error and then you don't have any work showing. Okay, so we have to make sure, and it will tell you on the test, and make sure it's in degree mode what they are. We do second cosine, and then we're doing 15 divided by 20. And we're going to round for angles to the nearest whole number. Okay, so 41 degrees, yes. So X is approximately 41 degrees.
We have to put the sign approximately. We cannot put...
Nah, you could just put the degrees. Yeah, I'm not going to ask you. Like, it's just going to have a blank. Yeah, it would have been like this. I would have just said put 41 right there. Like that. Yeah, okay. You don't have to put the degree sign. No. So Here's another flagpole scenario. So here's like the first one, they kind of gave you the drawing. On this one, I'm just gonna use my little tool to create. So every time we're gonna deal with a right triangle, and I'm gonna have this one go in a different orientation just so we understand. We're gonna have the same relationship. So from the point on the ground to the base of the flagpole, okay, this would have to be the actual flag, right? Base on the ground is here, so that's the 12 feet. Angle of elevation is 53 degrees. The angle is always made with the horizontal. So there's the 53. The question is asking how tall is the flagpole? So that's the vertical distance here. Okay? So now we need to label our sides. Circle the angle. X would be the opposite. The 12 is the adjacent because it's next to the angle. So what trig function? Yes, tangent. Good. So we're going to write, let me write this out, sorry. The tangent of the angle 53 equals opposite over adjacent. So that is x over 12. And then we just have to remember what to do when x is on top. So if you need, multiply. So if you need to make a little note of that, it is on the fact sheet. So if you go to the front of your pink paper, it's down here at the bottom. So there's your trig ratios and then what to do for each scenario. So if you want to add that, you can, but yes. But if you know it, you recognize it, you don't need to make a note of that. So we know we're going to multiply. So that means my x equals the 12 times the tangent of 53. And this part here is the calculator part. Okay. So we got to put that in the calculator. 12 times the tangent of 53. And because we're doing a side, we have to round to the nearest tenth. Okay, so 15.9, yes. So I'm just going to write it over here. X, well, actually, I'll put it up here. 15.9, okay. Okay. All right, so same scenario here on 39. Got a cable supporting a tower with an angle elevation at 78 degrees. So when you sketch, every time when you're drawing, if there's no picture, we should be using a right triangle. And it does not have to be to scale. So just draw a generic right triangle. The cable, the tower being 245 feet, that has to be this vertical distance here. Angle of elevation, that's with the horizontal, so that's 78 degrees here. And then they want to know how long is the cable. That is the hypotenuse, yes. So we have the opposite and we have the hypotenuse. So that is sine. So the sine of 78 equals opposite the 245 over hypotenuse, which is x. So this, now the variable is on the bottom. Do we remember what to do when the variable is on the bottom? Divide. Very good, divide. So just kind of switch this, put this sine of 78 to the bottom, and put your x on the other side. So to get our x, we're doing 245 divided by the sine of 78. Okay, and that's what we're typing into the calculator. Oops, my pen's not working. Oh, because it's not on. This is the calculator. Isn't it to the nearest cent? Isn't it 250.5? Yeah. Okay. So in a problem like 40, same scenario, we're going to just start off with a generic right triangle. Okay, triangle's crooked, but let me fix that. It says 60 block of Powell Street. And San Francisco has a steep rise. So, and it says right here, it takes 64 feet along the horizontal. So the horizontal is here at the, I said 64, but 66 right there. But it says a rise. So every 64 feet you move, it's rising up 10 feet. So that would be the vertical distance here. It says, the question is, find the angle the street makes with the horizontal. Well, the horizontal is down here, so we're trying to find this angle here. Okay, so because x is in the inside, we have to use the inverse to find the angle. If I look across, my 10 is the opposite, and my 66 is the adjacent. So to find x, we're doing tan inverse. Good. Opposite over adjacent, which is 10 over 66. So we have to put that in the calculator, and we're going to round to a whole number when we're doing angle measurements. So we're going to do second tangent 10 divided by 66. So this is going to round to 9 degrees. All right, so number 41 is similar to number 39, another cable, another tower, okay? On 42, they kind of gave you the diagram, but you have to label it according to given. So this is modeling using this kind of ray to attack some cells. So it says right here, the angle that the tumor is right here is 6.3 centimeters below the skin. So this is your skin. If I go below, this is where the 6.3 is. It's this vertical distance. And then it says the ray enters the body 9.8 centimeters to the right of the tumor. Okay. So to the right of the tumor, that's the 9.8 here. All right. So now they want us to find the angle right here. Find the angle the ray must enter the body. All right. So that's this angle here. And if I label the sides, we have 9.8 is the adjacent. This is the opposite, the 6.3. So for opposite over adjacent, very good. X equals tan inverse of our opposite, the 6.3 over 9.8. So we have to do second tangent 6.3 divided by 9.8. And we're going to round to the nearest whole number for degrees. Yep, 33. Okay. All right. Now on the back, the next page, we have a ramp for a skateboard here on 43. Just kind of just go over. Remember, there's no picture. You just start off with a generic right triangle. The ramp that is 16 inches high, the angle formed by the ramp and the ground is 21 inches. They want to find the length of the ramp. So if it's 16 inches high, that's this vertical distance. So that's the 16. 21 degrees with the ground. That's the 21 should be above the horizontal line. And it says, what is the length of the ramp? The ramp is the hypotenuse. So if we look here, we have the angle 21 degrees. This is opposite hypotenuse. Okay, sine, yep, sine of 21 degrees equals the ratio opposite of hypotenuse, which is 16 over x. And again, if the variable's on the bottom, you have to do what? Divide, yes. So 16 divided by the sine of 21. Okay. And then we talked about ladder problems yesterday. Okay, remember the ladder can't be standing straight up, it can't be vertical, it has to be slanted. So in this scenario, we're starting off, it says that the ladder should be placed against the wall at a 78-degree angle with the ground. Oh, so I got it. 75, sorry. 75 with the ground. So right there, that's important. The ground has to be the horizontal. So this is my 75. It tells us also that if the ladder is 14 feet long, well, the ladder is leaning against the wall. So that would be the hypotenuse here. The question is, how far from the wall should the base of the ladder be? How far from the wall is the horizontal distance? So we circle the 75, which is our angle. X is the adjacent. 14 is the hypotenuse. What trig function deals with adjacent and hypotenuse? Very good. Cosine of the 75 degrees equals adjacent over hypotenuse, so that's x over 14. Okay, the variable's on top, so that means I'm going to multiply to get my answer. So we're doing 14 times the cosine of 75. And this is the part that goes in the calculator that you need to show so that you can still receive full credit if you make just a typing error or something like that. So we're going 14 times the cosine of 75, 3.6, yes, okay. And then the last thing I want to talk about is this last problem, okay. The diagram is given and it's already labeled for you, but I want to make sure you're using or you're setting it up correctly. So it tells us the height of the bird, 40 feet right here. The bird's trying to get on top of this wall, which is 8 feet. And then it says right here that the top of the ledger, there's a 22 feet angle of depression. So they made this horizontal line and the angle is with that horizontal line. So what you're going to need to do to use trig to find how far the bird is, you're going to have to end up, let me get my pen here. You're going to have to end up drawing another horizontal line here. Okay. Because we need to create a right triangle. So if I do that, this is going to be the 22 because they're alternate ends here. The line, the site right here, this is the hypotenuse in the right triangle. But now I have to use this distance being 8 feet. That means the whole thing's 40, but this we know is 8 feet. So I need to find this distance in the triangle. Yep, it's 32. You just subtract 40 from 8, or 8 from 40. All right, so now I have the right triangle I need to use because I'm going to focus on this this triangle inside here. 24 is my angle. 32 is the opposite. Oh, sorry, 22. I wrote 24, sorry. 22. 22 is the angle. This is the opposite, and then x is our hypotenuse. So yeah, sine of 22 degrees equals opposite over hypotenuse, which is 32 over x. And we're dividing to solve it, yes. (32) divided by the sine of 22. 85.4, right? We okay on that? All right, so on your word problems tomorrow, it's either the picture is going to be given to you or part of the picture is going to be given. You have to add some of the labeling or no picture at all. Are we okay on that? All right, so now, so which are the like terms? Yes. Alright. Alright, I'll fix that later.
What? Oh yeah, it was.